All right, welcome back into this lecture 20 already. Oh my goodness, we're just moving along very well now. As we continue on our section on PLSQL, and in particular this lecture we are going to cover triggers and touch briefly on packages. Should be great fun. As per our usual standard practice here, it's time now to pause, download and open up lecture20scripts.txt. And if you'll notice at the top of that script, there's a create table product audits statement. Go ahead and fire that guy off because we're going to need him for the trigger we're about to create. All right, let's get started. All right, you say, but Rick, is this table setting ourselves up to audit changes to the suggested price of a product? And the answer is absolutely. It certainly is. Again, your next question ought to be, well, Rick, isn't Oracle just jam-packed full of auditing capabilities already? Why aren't those just turned on and running to take care of all this on our behalf? Well, the short answer is yes, Oracle does have a lot of auditing capabilities built into it. But on normal standard large production systems, only a very few are actually turned on. Somebody gets granted admin privs, resource privs, something like that. Very seldom are full-blown audits turned on simply because the performance gets killed. The only real times I normally see it is on accounting systems, and that's for whatever that Oxfam hardly or whatever that rule is that they got a Oxbane something. Anyway, doesn't matter. Like I said, really the only times I ever see it are on accounting systems. That being said, what does one normally do with respect to audits? Well, you build behind tables, and those are tables which simply sit mimicking the standard table. And you have triggers put stuff in there based on particular actions by people in the environment. And again, it's normally just the base tables that you're auditing. In our case, we're going to take a look at anybody who makes changes to the products table, in particular the suggested price of a product, because that's a pretty big deal. And you want to know who did that and when did they do it. Sometimes it's been my experience that people forget that they made these changes, and it's just a whole lot easier to give them a little nudge and help them remember when you've got the data right in front of you. So that's what our trigger here is going to look at. We're going to look at auditing modifications to the suggested price of a product via trigger. Cool, let's get started.
You know, many lectures ago in a galaxy far, far away, we briefly looked at a trigger for assigning a sequence.next val to a primary key. Common usage, but probably even more common, is to use triggers to realize the auditing of particularly important base tables. In general, you don't want every Joe Schmo changing this data, pricing, employee info, stuff like that. As such, let's check our trigger declaration statement. Create or replace trigger audit product suggested price change before update of suggested price on products for each row when new dot suggested price not equal to old dot suggested price. All right, I'm sure you're getting pretty comfortable reading this type of syntax by now. Create or replace a trigger named audit product suggested price change. The next line is new, so let's discuss it briefly. Before update of suggested price on the products table. All right, pretty straightforward. This trigger will only fire on updates to the suggested price field of the products table. Of equal importance, it will fire before the updates such that any unacceptable changes might be prevented. Okay, not too much going on here with the declare section. Other than the presence of this fake user ID variable, what do you suppose to deal with that guy? Well, you're all programmers, so you of course have already guessed what I'm going to go here. Under most situations, your web server is going to connect to your database through predefined connection methods, not as an individual user. Instead, the application will connect to the database, prompt the user for a password and username, and then actually verify that information via the already established database connection. Once so verified, the user, or more likely an associated user ID, is going to be carried around by that user so we can audit their activities within the database. Yes, every time they do an insert, update, or delete, we are likely to record that user ID and the system date time to the same record, just in case somebody forgets having made that change. We don't have that same information here, so we are simply going to fake it with this variable. But remember, when you're building real production applications, that you'll need to be passing that user ID as part of just about every DML statement. As with the credit card people say, don't leave home without it. All right, the next 2 paragraphs of code check whether a basement audit record exists, and if not, then it's created. A basement audit record simply sets a baseline value in the audit table should we wish to perform any between date queries. All right, the next 2 paragraphs of code, we get the relative magnitude of the proposed change, and then boot the user out if the transaction should exceed a change of plus or minus 25%. All right, here in our last paragraph of code, we're actually creating the audit record. Not much interesting going there either. All right, let's run a very quick test just to prove to ourselves that things are working properly. We'll start with the update and then a simple select star. Okay, looks like the trigger worked fine. Now, let's query that audit table again with a little more standard looking query. Did you notice how I had to add a users table and add my user ID 100 records so the more standard query would operate properly? Other times I do a date between function, which really brings a baseline record into play. Hey, when was the first record inserted into the products table for this product ID?
All right, enough on triggers. They're really pretty straightforward, and again, really the only time I see them being used is to set sequence or to do auditing, because the whole mutating trigger just makes a mess if you put any real logic in there. Let's move on to packages. Okay, caveat here. We can't get too deep into packages in this course. It's simply beyond our scope. And we're going to take a look at a very simple one here that doesn't, quite frankly, won't even compile. It's just going to give you some ideas as to the basic structure of a package. If you truly are interested in this, first off, I recommend that you give yourself 6 months, even a year of practice on standard SQL and PLSQL functions and procedures, and then you're ready to step up to the plate for packages. Packages are, in fact, building full-blown programs inside of Oracle, and it does take a little experience with the basics before you're ready to jump in there. When you are ready to jump in there, please also know that I am going to offer a more advanced course on PLSQL coming out in the second quarter of 2017, so please jump into that guy and check out more advanced PLSQL packages at that point. One final word on this package we're about to look at. Don't try to compile this thing. It's mostly comments. It's what we would call pseudocode by most of us. I just wanted to give you guys a taste for what this is, and also to demonstrate some of the uses of the Oracle pre-built packages, which are extremely powerful and give you a good leg up on package programming yourself. So we'll take a quick jump in there.
Last thing, this is how you declare a package. Should be no surprises here by now other than this authid definer clause. All this says is that the public may execute this package with the privileges granted to the package's creator. The alternative here is authid user. Net with definer, you typically get to do stuff you otherwise wouldn't do as Joe's standard user connection. Next, I define a bunch of data structures to be shared by the local procedures and functions. Again, I really don't want to get into the details here because they're beyond our scope, other than to say these are user-defined temporary storage objects. Next section of the package defines all our public procedures. Our particular example here didn't have any, but it could have just as easily had public functions in there which were exposed to the public. Finally, I define a couple of package-specific public exceptions. If this were a real package, I would need to document these to you as programmers such that as you're writing interfaces, you could deal with those exceptions in an appropriate fashion. Now please notice how the package body has its own separate and distinct declare statement. What goes on behind those closed body doors is not available to the public. That's the whole idea here. Only that which is exposed in the above package declaration is available to the public. A couple of things to note about these hidden procedure shells. First, the load customer specific procedure has a local procedure of its own named local parse routine. The scope of that procedure is limited to the load customer specification procedure. Compare that to the build DDL procedure at the bottom of the package body. The scope of that procedure is the entire package. Any of the other procedures within this package may call that procedure, but it is not available to the public because it is not defined within the package declaration. Last thing, check out this util file thing here. Suppose it's just another package, this time supplied by Oracle for managing file reads and writes. Yup. The getLine function is just another function within the util file package exposed to the public for use by other PL/SQL coders like ourselves.
All right, that was great fun. We also concludes our look at PL/SQL. I know we touched only briefly on packages, but again, just a reminder that if you are interested, I first recommend 6 to 12 months of practice using the standard PL/SQL functions and procedures so you get those under your belt, and then come back and we'll talk about packages in much more depth in a subsequent course. For now, PL/SQL, what did we learn? Well, first, PL/SQL is the procedural language extension to Oracle's SQL. A very powerful tool. Differs significantly from what you get in SQL Server, where it's TSQL and really is nothing more than a transaction-based language. PL/SQL is a full-blown programming language and quite powerful and robust. We use it to create 3 differing types of code triggers, which fire in response to the update, insertion, or deletion of a record from a table. Procedures and functions, both of which you guys are very comfortable with because you write them every day in your 3GL programs. And then, of course, the ability to put procedures and functions together within a package shell, where in addition you can add local data structures as well as user-defined exception handlers. All good stuff. And finally, please remember my warning about triggers. It's not where a whole bunch of logic, and particularly DML, should live, because you will be bitten by the mutating trigger monster eventually. And once you are, you got a whole big bunch of mess that you got to undo and take that stuff back out. So best not to go there in the first place. All right, that concludes our discussion of PL/SQL. In our next section, we're going to start to look at what I'm describing as less frequently used techniques and strategies, and in particular, we'll begin with user-defined types. Interesting from a theoretical standpoint, but not used as regularly as the SQL and PL/SQL techniques that we've discussed up to this point. In particular, what we're going to look at in the next section is a lot of stuff that is going to be on the certification exams, and it is important in that right Also important from a practical standpoint in that occasionally you'll touch on this stuff, but unlike SQL and PLSQL, you won't be using these techniques and strategies on a day-to-day basis. Looking forward to checking you out in that next section, and in the interim, you go out there and have some fun, but learn something every day.